In this new episode of the podcast, you will discover how people in space missions are also looking into their sustainability impacts. It is reassuring to hear this. Another place like the ocean where we thought we could just dump trash into and forget it. But now, as we will see with Alessandra, the industry is looking under the carpet and they are measuring. It won't be easy, but it will be a great exercise to also improve sustainability on Earth. Because as it has happened in the past, when we address the challenges and the discoveries in space, that knowledge comes down in our daily life to change our perspective for good. The episode is great both for those who think we should explore our plan B in the space and for those who are very focused on Earth. Alessandra links the two of them beautifully for us, and she touches on the future of many industries. You will love it. Sustainability at Work is a podcast about sustainability in the workplace and in companies. My name is Samara and I've been working with sustainability for almost 10 years. Hello, good morning Alessandra. Good morning everybody. Welcome to Sustainability at Work. How are you?
I'm very good, thank you. How are you?
Very good, thanks. Thank you for being here. I'm very excited for this episode because this is the first time. Yeah, this is the first time that in the podcast we are talking about space, sustainability in space. So I'm so excited. I have so many questions and so many curiosity. So I'm going to go directly. Alessandra, you are involved in so many things. So I'm going to ask you if you can introduce yourself because I think I'm going to miss something. So better if you do it.
Right, thank you. So I'm a master's student in EPFL, which is a polytechnic university in Switzerland. There I'm studying space technologies and robotics. And I'm getting closer to graduating. So I'm about to start my master thesis working on LCAs for a space company called ESO, the European Saturn Observatory. So
LCA is life cycle analysis.
Life cycle assessments, yes.
Mm-hmm. Okay.
Yes, so trying to estimate what are the impacts of the projects that they're doing on the environment and how can we have like a carbon budget that we put at the beginning of a project so that we can try to reduce environmental impact before the start of a project. So that's the general idea so that we can like use the carbon that we have for a project in a smart way, not waste it. That's the topic of my master thesis, but in parallel, I'm working on different other projects, namely the SSR, which is the Space Sustainability Rating. It's a very new idea that had come out from a very big consortium of the World Economic Forum, MIT, the University of Austin in Texas, ESA, Bryce Space and Technology. So they met together, they developed this rating system with the objective of being able to assess the sustainability of a space mission, a space operator, which is really first in their kind. There's nothing that is doing this work right now. So they really try to put in place, how do we say this mission is sustainable and how much? Try to provide recommendations on how to improve sustainability of a space mission, and then finally try to incentivize sustainable behavior and have operators try to use a more sustainable thinking and sustainable operations during the operation of their spacecraft. So the idea is to have this label which will rate the space mission, and EPFL, my university, has been chosen to operate and to make this rating work. So I'm in parallel working with them on this topic.
So before we dive more into what you are doing, more generic approach, or what is sustainability in space? What are the problems that we are trying to address? What are the biggest challenges?
Yes, that's a very good question, very good point. That I think it's interesting to see also how sustainability is differently defined based on the field that you're looking at. So in space, what we mean, at least with the SSR, what we mean by a mission to be sustainable in space, it means of ensuring the possibility of using the space for the generations to come and protecting current activities, space activities that are going on. So being able to operate something in space in the next generations, this is not something that is for granted, mainly because of the issues of space debris. So the idea is that thousands of spacecraft has been sent in orbit in the last 60 years.
And also Tesla.
Yeah, and also Tesla, exactly. So it's a lot of useless trash when these spacecrafts or a Tesla and like finishes its purpose, like their mission, they don't work anymore. Like stuff on Earth, like a phone, when it stops working, you throw it away. In space, you don't throw it away, just leave it there. And that's the issue, because there's a lot of trash. It's actually called space junk, which is left there orbiting Earth. Most of it, it's very close to Earth. Actually, it's in the LEO, so low Earth orbit. And this orbit has become so crowded of debris because part of them are just spacecraft that don't work anymore. Some of these spacecraft have exploded because of energy like stored in the spacecraft, which is not well managed, is not disposed, and so it makes spacecraft explode in many smaller pieces. Some of these spacecraft, working and non-working, have been hit by other objects, so other meteorites or other spacecraft or other space objects, which have created collisions and a spike in the amount of debris in the orbit. And what happens, like the consequence is that these orbits are full of debris of like 1 centimeter small. When they hit something in space, they can have the strength of a hand grenade, like the velocity at which they're traveling and the relative velocity when two things collide, it's incredible. And the effect, it's really an explosion, which creates
I think we have seen it in Gravity, right? In the movie.
Exactly. Gravity is a great example. Like it really shows how that's an issue even for the lives of the astronauts on the ISS right now. Or it becomes dangerous for astronauts to get out of the ISS. It becomes dangerous even to stay inside if the ISS is hit by something very big or in a dangerous spot. So it really poses a threat to that. And it can really harm current satellites, like working activities. So if you have an operational satellite and it gets hit by a piece of debris or something that we cannot detect, or we can detect, but the satellite maybe does not have capabilities of moving around, of avoiding the debris, then it might risk of being like a serious damage on the spacecraft and ending its operation and destroying it. Mm-hmm. So this poses a threat to all of the useful activities that we do in space that are helping us on Earth, for example.
In a way, I see this problem a little bit like the ocean. We think it's so big that we can just throw everything inside and you don't see it. It's not a problem. So, and I think space is even bigger. So exactly. I guess for years we have just thrown things there, thinking that they were going to disappear, and just not our problem.
Exactly. I actually have an analogy with the ocean itself, because one of the problems is that what is most efficient would be to take out those debris from space when they are like a whole spacecraft, when they're big, let's say. So like in the ocean, if you throw away a plastic bottle, you can easily pick it up. You just have a plastic bottle, you take it out, that's it. But if you leave it in the ocean, it's going to degrade in smaller plastic particles, microparticles. At that point, it's almost virtually impossible to take it away. Same thing in space. So if you have a big spacecraft, it reduces in smaller debris. Once they're very small, they're very, very hard to take away.
So I was going to ask you, with the metaphors of the sea, because we have done an episode also on marine litter and everything. So what are we doing at the moment for this problem? Are they handling first? And then if you can explain a little bit more about the orbit, because when I was reading for this interview, I discovered the things of there are orbits that have purpose, and there are different orbits with a different purpose assigned, and there is even, it's like a landfill very far away that you just try to throw everything. I thought it was very interesting. So if you can talk to that.
Yes, absolutely. So regarding orbits, what happens is that when you send stuff in space, you can choose the orbit that there will be around Earth. You put them in a certain orbit depending on what you want them to do. The closer you are to Earth, the more you're affected by this kind of like drag. So the higher you put the spacecraft, the slower it will take to fall back down on Earth. And there are the LEO orbits, the low Earth orbits that are very close to Earth. So from 200 to 2000 kilometers altitude. Sorry. And then you have the geo orbits, so the geostationary orbits, which are 36,000. So they're very, very far. And those are the orbits that you reach if you want to have, for example, GPS satellites are up there because they can follow, they can track Earth. Their period is the same as Earth turning, so they will always face the same side. So in those cases, and then you have middle orbits, the MEO, the medium Earth orbits, which are a little bit yet less used, let's say, for this matter, for space debris, they're a little bit less concerned. So the geo orbits are very far. So what you do when a spacecraft ends its life, like they don't operate anymore, they're broken, you tell the spacecraft to fire their engines or to use the last fuel that they have to go farther, even farther away. So you put them in this landfill area that you mentioned, where at the point they kind of just stay there because the time that it would take for them to go back to Earth, it's almost forever. It's like very, very, very long. So that's the solution that we adopt. We just push the problem away in time by pushing the spacecraft farther away. While on the LEO orbits, the one closer to Earth, you cannot do that because you're very close to Earth. If you put it farther away, it's gonna come back in a small time frame, let's say. And also you can completely take out the satellite from orbit. So you don't have to postpone the problem. You can completely take it out by pushing towards Earth, because in the re-entry with the atmosphere is so thick after a while that it will start demising the satellite. So it will start decomposing, like burning while it re-enters, and get destroyed in very small particles. And so you can get rid of the problem by taking the satellite, putting it towards Earth, and making it destroy. So that's one of the things that it's being currently done, let's say, to solve the problem of debris. There are some norms, some suggestions, let's say, from space agency for space operators to have a strategy for the end of life of the satellites. So when a satellite, it doesn't work anymore, what do we do with it? How do we deal with its disposal? Like on Earth that you look at, what do you do with the waste? So one of the things that they always try to have is this re-entry to Earth. So have the spacecraft come back to Earth and destroy in the atmosphere. And sometimes when they calculate that this is not possible, then they try to have a controlled re-entry and so make it fall, for example, in the ocean or somewhere where it's safe, and then they can be taken out without hurting humans. So this is one of the first things, but this is not a compulsory practice. So you can do it or you cannot do it, and unfortunately, a lot of people don't do it because it costs. It costs fuel. You have to make sure that you have some fuel left at the end to put it down. And in space, mass is the one thing that you need to reduce. So you have to save on mass. So bringing extra fuel just for the disposal, doesn't look attractive for many space operators.
And that was one of the questions that I had. I mean, I guess there are no regulations at the moment about this. So no mandatory eco-design of satellites for end of life. What are the tools that we have to enforce sustainability from this point of view of debris in space? I don't know, insurance, maybe cost of insurance that are going up. I don't know, funding that is taken away because they're not sustainable. I don't know. What are the tools?
That's a good question. I think it's very... not debate, but it's something very new that's coming up, let's say. So this issue is recent in the sense that people started to realize how many debris we have, and also started to realize how many more we're going to send because of this new space economy that's coming up. So private actors getting into the field, so sending more and more things, mega constellations and all of this. So it's becoming a very urgent issue, but in recent times. So regulations have not been able to catch up. And there isn't any enforcement of these rules. What the SSR, for example, wants to do, the space sustainability rating that we're working on in EPFL, is to try to put advantage, to give an advantage to space operators which are thinking about these things, which are thinking about end-of-life strategies and demisability and so on. So the objective would be to give them some kind of incentives and maybe advantages with insurances and so on. If you have a good sustainable label, let's say, if you are more sustainable, then you could have some incentives, also economical. But it's very new, to be honest. There isn't anything really working right now.
Yeah, I guess maybe finance is going to help on that side, as it did with sustainability everywhere. So I heard that this year is going to be the year when the first certification is going to be released. Are we there already?
Indeed. Yes, we're almost there.
So what is the certification? What is the score based on? Which are the main topics that it's looking into?
So right now there are different modules. We look at the mission index as the main important one, which is like the sustainability of the mission itself. So the orbit that you're going to go to, what's the purpose of the mission, and some kind of like general mission requirements. The orbit is very important because there are some orbits which are more full of debris than others. So even in the low Earth orbits, the one close to Earth, you have some spots which are some orbits that are very dense. And those are more dangerous than other ones. So where you put your spacecraft really matters. Then you have the trackability of your spacecraft. So how easy it is to identify it in space, to track it, to know where it goes. And also, what are your capabilities of controlling your spacecraft? So do you have fuel? Can you move it? Can you not move it? That's really important, obviously, if you want to avoid collisions. Then you have, if you're following some regulations, if you're following the standards. So, for example, if you have an end-of-life strategy, if you have a way of taking out the orbit from the space you're occupying, then you have extra points if you're following that, and you have extra points even if you are being transparent with your data. So if you're like explicitly saying, okay, I will take this out, I will operate in this way and this way. So there's a bit of a tricky part there because of many space operators are not very transparent with their space missions, or they don't want to disclose a lot of information. And so we're trying to find a good middle ground there where they can feel comfortable in telling us information without being too
revealing of the secrets.
Yeah, revealing. Yeah.
You talked about this new industry of private missions in space.
Mm-hmm.
And I guess that's very scary from your point of view of marine debris, of sustainability, because it's something that until we have a regulation, it's completely uncontrolled. And it's like in the past, traveling to wild places around the world was not a big problem because only few could afford it. Now, if you put that same place with the wild, untouched population on a normal trip that everybody can go, that's a huge sustainability problem. So I guess that's a little bit the same thing. How do you see it?
Indeed, it's really similar. The knowledge is very good. It's there are good sides, of course, in the private sector getting so involved because you have really a lot of technological advancements that are coming up very fast. Prices are going down for launchers. It's so much easier to reach certain orbits, to do operations that before maybe was harder because you have just few players, also fewer investments, let's say, in the industry, and so the advancements were slower. So that's good. Like, to be honest, from an engineering point of view, it's very exciting also for me to see, oh, we can do this and this and this, and it's cheaper, and it's very exciting. It comes, of course, with the drawback that this is not regulated. This is there's almost nothing that they cannot do. Like if a space company like SpaceX wants to do a mega constellation like they're doing with Starlink, they will do it. They have nothing that is holding them back. And now it's causing problems to astronomers that look to stars and they just see satellites coming all the time. It's causing problem to space debris because you're putting there like thousands of small satellites which have a small lifespan because it's cheaper to do them faster, and that they demand that they and like their end of life, it's very, very short. Like their life is very short. Sorry. So yeah, I think it's a controversial problem. Like if it's not regulated, of course, it's not gonna end well. Unfortunately, we need to think, like on Earth, we need to think of protecting the environment before putting a lot of players into the game, let's say.
Many people who are involved in sustainability, sometimes they say, why are we investing so much money to go to space when we could invest that same money to implement a sustainability measure here, that we need so much money? So what is your answer? Because when we talked before this interview, you wrote me something in an email that was like, the space sector has a big impact on the sustainability development. So I guess those are two views. So why the space is a big player?
I think one of the most clear examples that happened kind of recently was the IPCC report that came out this year. I don't remember exactly the percentage, but the biggest majority of the information that they have to be able to assess that it's humans that are causing most of the climate, the warming up the environments that we're experiencing, all of those data and information are coming from space. They're coming from space satellites. So Earth observation satellites have been so fundamental in understanding how we are impacting the environment. You don't see, for example, decreases, the shrinking of lakes or deforestation in any other way than from space images, from space satellite images. So this is already fundamental. Like we cannot be able to act on anything if we don't know what the problem is at the beginning. So just being able to monitor what's happening on Earth, which can only be done by space, to me, that's already a good enough reason to put satellites out there to be able to, understand what's happening and understand how this is reducing the warming of the shrinking also of the ice caps in the Antarctic and Antarctica. They both cannot be seen other than from space. So that is one of I think the main reason why space is so important for sustainable development. And then you have all the other services that space is providing to us, which we give for granted maybe. There is, for example, if there's a fire or if there's some emergency that is happening somewhere in the world, you can detect it from space much faster than you can from Earth. There has been satellites used for example, tracking elephants to avoid poaching, or tracking. One of my friends in university actually developed. He studied a system to track whales to be able to not have ships run over whales and kill whales, for example. So there are all of these kind of like protection systems, let's say, that we could put in place from space. And then it provides us with for example, weather forecasts, which can be useful in many situations. They provide us possibly internet coverage all over the world, which helps in the development of like third world countries, which need, for example, that internet access, and we don't have the facilities, the physical facilities to bring the internet through a cable. All of those kind of GPS, sorry, that's another very important, for example, tool that we use every day, and it's improving our lives. It's helping our sustainable, let's say, development of our society, but we just give it for granted in a way because it's always been there, but it comes from space. Like it's not It's not something we can do without space. And the amount of investments that are put in space, like from each country, they're very, very small. Again, I don't remember exactly the number, but I think in the US, it's like 1% of their budget goes to space development. So it's not like we are spending like the majority of our, let's say, budgets on the space sector and then thinking, oh, on Earth, it doesn't matter. On Earth, it matters the most. We should spend the most on it. But it doesn't mean that we cannot also have a space field, which is still bringing a lot of innovation and technologies which are helpful on Earth too. There's even, just to end, there's a lot of technologies, for example, that have been developed for astronauts or for the rovers that are going on Mars. Like what they've invented for that, for example, sorry, I missed the English word, the respirators now that we're using for COVID for, like that kind of technology was first developed for space and then it's been adapted on Earth.
A lot of materials too. A lot of materials, exactly. Textiles, yeah.
A lot of technologies that we don't expect in the medical field, in the sports field, let's say, in very different range of fields that they have been developed for these extreme conditions, and then we could use that for Earth too, and then adapted on Earth.
And then I think we cannot forget that in a way the sustainability movement started with the Earthrise picture. So maybe
exactly
that point of view outside of our Earth was the very beginning of starting to take care of Earth and see it as it is in the middle of space, which is kind of scary place and empty place compared to life on Earth. So yeah,
it really does give this different view of Earth. And I think I heard a lot of people, of my friends and the people that I know in the field, that really see space and the space sector as something where we're all united, really. Like, you don't see boundaries, you don't see, you really see the fragility of Earth and how pointless it's to get lost between us humans on like political divisions or these other issues when we have one planet, when we have this, we're all on this together, and it doesn't really matter if in which country you're born, for example. So it's a different, I think that also the different perspective, it's very important. It really changes the way people see things.
I agree. So a lot of your work is based on measuring the impact of emission, measuring everything, and then you have also a private project which is EcoLens, if you want to talk about it, but it's also based on measuring. And my question for you is, I'm a big fan of measuring. I guess you cannot improve what you don't measure. So, but is measuring changing the behavior of people? And I think you maybe have a taste of that with your project with EcoLens, because space is very far away, but EcoLens is more focused on something that is in our daily life. So what do you think?
Yeah, so EcoLens, it's a project I did, indeed, as you said, like by personal passion and involvement. And it's a way of measuring. It aims at measuring the environmental impact of the meals in restaurants, especially in my university, and trying to transmit this information to the public, to the community of EPFL, and hopefully try to push towards a more sustainable consumption by informing people and by giving some kind of reward in eating sustainably. I think that it's very hard. It's very, very hard to change behavior, and especially in the food sector, I've noticed it's very challenging. And as you said, I still believe that measuring is so important, because if you don't measure, you don't even know how much it's an issue. So I think that that is always the starting point. And unfortunately, I've noticed that in many these life cycle assessment or these environmental measurements, we don't have a very high accuracy, we don't have a very high precision, or it's very hard to be able to estimate exactly what is more impactful. So this information is sometimes also not arriving to the end customer, which then doesn't really know that they have a choice of buying more sustainably or eating more sustainably. I think it's a mixture of factors and of communication factors to the end user, but also of more technical, like at the start, like how do we actually measure it to make it that it makes sense, and that we can, have a standardized way of doing that. I think it's still kind of a field that needs research and needs work. So I'm happy to be on that side.
I would think that somebody who is studying the life cycle of a mission in space would not be threatened by trying to measure the life cycle of a piece of meat. But no, that's also challenging.
No, I'm more scared about a piece of meat than the spacecraft.
That's funny. So just to close up, this project, EcoLens, allowed you to go into a trip to Antarctica. How was that trip? Did it change something on your perspective about sustainability and climate change?
Absolutely. Well, the trip was fantastic because Antarctica, is the most non-Earth place on Earth that you can go to. It's really, if I would like to go to space, but going to Antarctica, it's the closest thing that I could do. It was really a forming trip also because it really helped me get a different perspective on traveling, on the world, like the environment in the world. Like Antarctica, it's just so well preserved in a way. We managed somehow to not have companies get there and just extract resources. And all that it's done on Antarctica, it's research, it's scientific research. There are just a lot of bases from many different countries which are collaborating to do their own research. And a lot of that research has helped proving that climate change right now is caused by humans, and there has never been the spike in CO2 and the spike in the warming of the Earth in the past many years. So it's been fundamental, and it's been a great example of cohesion and on how we can really all work together for something that it's useful, and we can really all work together to preserve an environment and to not waste it in a way. So it was interesting, to get there and never see plastic, for example. It's maybe something so dumb, but we stopped in different islands and there never was trash. There never was pollution, even in the air. You could kind of feel it. So that was very beautiful to see that we can still be able to preserve something like this. And that was not always the case. For example, we first stopped in South Georgia, which is an island very close to Antarctica, in the very south of Argentina, on the same latitude. And South Georgia has been destroyed by whaling in the 80s, and a lot of seals had been killed and used for meat and for selling, and all of these had been banned. So the nature started getting back and really started restoring itself when humans had left the place. So it's beautiful to see how even if we do something wrong, even if we kind of destroy, let's say, an environment, this can come back. If we give it the chance, nature is going to restore itself. Nature is going to fix itself. And really, it doesn't matter if we fix climate change for us or not. So if we don't do anything, if we get to a point where humans destroy themselves by their actions and so on, we might, our species might not have a good ending, but on Earth, it doesn't really matter. Earth is going to restore itself. Nature is going to restore itself in a way. So really, the climate change problem is not about preserving Earth. It's about preserving humans it's about preserving our species and hopefully not damaging everything that is around us. But it's really a matter of us. Antarctica, it's going to be Antarctica even if we all die. You know, it's really, it's this enormous thing that makes you kind of reevaluate what is your position with nature. We are benefit from it, but we're not essential for it. So I think that really changed my view on that. And it really changed also my view on tourism, on the importance of sometimes caring and being close to these environments, these different points of view, these different species, and really the fact that the world that I know, it's not necessarily what's happening everywhere else. And that puts it in perspective. So I think it was very nice to see that, you know, it was a trip that it was worth it. It was worth it for me, at least.
I think that's a beautiful closure to our episodes. Thank you so much for sharing all this information, thoughts. I think it was a beautiful conversation, at least for me. Thank you so much. Thank you, everybody, for listening. And I see you next time. Thank you, Alessandra. Bye.
Thank you. Bye.